sir. We are Group Panonggab and we discuss our topic is bubble sorting algorithm. For now, I'm discuss the bubble sort algorithm. So for our step one, start the algorithm. Read list of number in A and determine n equals length A. Set I equals 0 for the first pass. For second step, we compare the adjacent element from J equals 0 to J equals n negative 1 negative I. For each J, compare A and J and AJ plus 1. If AJ greater than AJ plus 1, swap them. Move to the next J. After finishing this entire pass, the large element moves to the n. And for our step 3, set I equals 1. Now compare only until n negative 1 and negative I. Again, compare each adjacent pair, swap if needed. After this pass, the second largest element moves to the second last position. For step 2, continue process. Repeat. Increase. For step 4, repeat. Increase 1 I by 1 each time. Compare elements from J equals 0 up to J equals n negative 2 and I. Swap when needed. Each pass shortens because the biggest elements are already sorted at the end. And for our last step, when I reach n negative 2, once I n negative 2, the array is already sorted. So we exit the loop and the procedure ends. For my last discussion of the algorithm. To sort an array, multiple passes are employed, where in each passes, the maximum unsorted element is placed in its correct positions. After k passes, the large k element are relocated to the last k positions. During each pass, we have compared the neighboring elements and swapped them as needed until the largest of the remaining elements is correctly positioned.
Bubble sort is a basic sorting algorithm that works by repeatedly comparing and swapping adjacent elements. It checks two items at a time starting from the left, and if they're in the wrong order, it switches their positions. This process continues across the entire list, and with each pass, the largest value bubbles up to its correct position at the end. The algorithm repeats these passes until no more swaps are needed, which means the list is fully sorted. Bubble sort is easy to understand, but it's not the most efficient for large databases. For example, when we look at the first two elements in the first two boxes, it's 5 and 67. So since 5 is smaller than 67, it's already on their correct boxes, since the left hand side should have a smaller value than the right hand side. And then when we look at 67 and 890, it's still on the proper position since 67 is smaller than 890. And when we look at 890 and 1388, it's still in the correct position since 890 is smaller than 1388. But when we look at 1388 and 45, we put the 1388 out of the way, so 45 can take over its place and 1388 can take where 45 was. Basically, they swap positions since a larger number should be on the right hand side instead of the left hand side. And this process repeats throughout the entire array to sort out from least to largest. Bubble sort works by repeatedly comparing and swapping elements until the entire list is sorted. It starts with adjacent comparison, where the algorithm checks two neighboring elements and sees if they are in order. Specifically, if the left element is greater than the right element when sorting in order. If they are out of order, the algorithm performs a swap, moving the larger value one position to the right. This process continues across the list, and because one full pass is not enough to sort everything, bubble sort performs multiple passes. With every pass, the largest unsorted element gradually moves or bubbles up toward the end of the list, which is where the algorithm gets its name. Lastly, Bubble sort includes an optimization called early termination. If a complete pass occurs without any steps, it means the list is already sorted and the algorithm stops immediately to save time.
Okay, hello again. And to start off, we're going to have a class named bubble sort, and then within that class we have a method called also bubble sort, which is then going to initialize n, which is equal to the array length, and then we have our first for loop, which is going to count the index of the array. The next for loop will then feature to count all the elements within that array. And then we have the condition, which is if array j is greater than array j plus 1, then, and if true, then it will start to do the swapping operation, which is going to be int temp is equal to array j, and array j is equal to array j plus 1, and array j is equal to the temp. Now we have the original sequence, which is going to be 5, 67, 890, 1388, 45, 124, 98, 380, 1325, 95, 49, 24, 89, 689, and 56. And to start off, we have the first element, which is we have here, and which is going to be counted for the second for loop, which is we're going to start off with 0. Then, so that will be the index, which is this 0, which is equal to 5. Then, we are going to compare it to the next element, which is array j plus 1, which is basically just 0 plus 1. So 0 plus 1 is equal to 1, and is going to be equal to 67. Now we are going to compare these two. Now, let's look at the numbers side by side. So the condition is if array j is greater than array j plus 1. But since that is not true, we are going to continue to move on to the next number, which is going to be the new number, which is j plus plus, will be equal to 1. So now we start off with 67 and 890. Now, since again, the condition is also not fulfilled, array j must be greater than array j plus 1, but since 67 is not greater than 890, then it will be set false, and add another count to the second for loop, which is then we're going to be now be 2. So it will be 1, since earlier we had 0, the first count, then it's false, then add 1 count, now we're 1, then since it's also false again, then we count again to 2. So now we are going to have the 890 and 1388, which is also again true since 890 is smaller than 1388. Now we're going to add another count. Now our count will be for 3. And here it is special because now the condition can be set to true, which is that if array j is greater than array j plus 1. So now we are going to set array j as the temp, which is then going to be, so I'm going to write it here, temp is equal to 1388. Then the new array j, which is 1388, 1388, then it is going to be then become array j plus 1, which is going to be 45. So that is the first swapping order. So 1388 will then become 45, and then the new 45 or array j plus 1 will become 1388. Now, after all of that, the numbers are swapped. So the new 45 will become 1388, and 1388 will become 45. And after that, we are going to add another count, which is going to be 4. Now we start with 0, 1, 2, 3, 4. Now we start with the new 45, which is equal to 1388. We compare it again to the next number, which is 124. So the basic run of the bubble sort is that if the left number is greater than the right number, then they swap. So knowing that, I am just going to speed run this. So 1388, is it bigger than 124? No. Then 1388 again. 1388 is greater than 9. No. Yes, sorry. Yes, it's greater than 9. 1388 is greater than 8. No. Yes again. Then 1388 is greater than 380. Yes. All up to 2489. Then the swapping stops there. So then we will be proceeding on to the new element since the condition will now be set false. And then just add another count to the j, which is going to be now 2489. And then we are going to set that as the new temp. Then again, with that swapping operation, it's going to be 2489, and it's going to compare to its right number, which is going to be 689. So it's going to be swapping again, and it's bigger, swap. 2489, bigger, yes, swap. Now, after the first pass, we will have this. The 5, 67, 890, 45, 124, 98, 380, 1325, 95, 49, 1388, 689, 56, and 2489. Now, after that, we are, as you may have noticed, the biggest number will naturally will become the last element, as with the bubble sort algorithm, the largest number will tend to be bubbling up, henceforth the name. And now we again move on to the passes, and we're in the second pass, which is going to be the same action all over again. If left number is greater than right number, then swap. So left number 5 is greater than 67. Is it true? No. So no swap. 67, 890, greater than, no swap. And now here comes the first swap, which is going to be 890 and 45. Now we're going to swap that. And then 890 and 124, swap. Then again swap with 9, 8, 380, all the way up to 1325. Then we stop there since the condition will be false. And then we move on to add another count to that, which then will become 1325 as our new temp. And then compare to its right number. Is it greater? Yes. Then switch. 1325 greater than 49. True. Yes. Switch up until 1388, which is then going to be the new temp, since it's gone. Since 1325 is no longer greater than 1388, then 1388 will become the new temp, and then go on. So 1388 is greater than 689. Yes. True. Then swap. Again, 1388 greater than 56. True. Then swap. And up until 249, which is then going to be false since it's no longer greater. Then after that, as I failed to mention earlier, after you're done with the each pass, it will then continue to add a count here, add to count here, so that we are going to be keeping track with each pass. So as you may have noticed here, it's n-1. This is n-1 because in bubble sort, when you are sorting the elements, the biggest element will naturally come up to the end of the array. Hence, always sorting the biggest number, or it's always going to be sorting the elements, which is going to be -1 from the array length, since we already know that the biggest number is going to be in the correct position anyway in the end. And again, since we already know the position, we don't have to go through all of this, but it's just going to be the same anyway. 567, no swap. 6745, swap, bigger, so on and so forth up until 380. 380 will become new temp, and go on. It's no longer bigger than 890, no swap, and 890 new temp. 95 greater than, swap. 49 swap up until 1388, no swap. 1388 will become new temp, and then 1388 689 bigger than, yes, swap. And then compare it to 56, then 1388 will become 1388 will then swap with 56, and then again compare it to 1325. Is it bigger? Yes. Then swap again, then compare it to 2489. Then the condition will then be set false, which is going to stop there, and add another count to our increment, so that will become our third pass. So on and so forth until the 10th pass, which is going to be set as our final pass. But although it doesn't end on the 10th passes, since there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements within the array. But since after the 10th pass, all the elements are going to be the same anyway, so I've stopped there, since this code does not feature detection mechanism, so that if there are no more passes or there are no more swapping that is occurring within the code, then it will automatically stop. But since I don't have that, it will continue on up until the 14th pass, since for our for loop, it says int I is equal 0, and I must be greater than n, which is the array length, -1. So we are going to stop at the 14th pass. Now, after running this, after inputting all the elements, let's see what will happen if we try to run. Anyway, so let me put this into an online compiler, as there seems to be a problem with my compiler. Now, online Java compiler. Now here we are going to use program is, and then input our code. Okay, ikat na lang sa dito like when it errors. Okay, 3, 2, 1, start. Okay, since I had a little bit of an error there in my compiler, I'm going to run it through an online compiler, which is going to have the same result, which is then going to show us, let's check if it's the same with our input earlier: 589, 45, 49, 56, 67, 95, 124, 380, 689, 890, 1325, 1388, and 2489, which is going to be the same as our final sorted sequence. Okay, now that is done, thank you for sitting there patiently and watching my demonstration of the code. Thank you.